In voltaic cells, the standard cell potential, or E naught of the cell, is the maximum electric potential difference or voltage of the cell operating under standard conditions. When we talk about standard conditions, we talk about 25 degrees Celsius or 298 Kelvin and 1 molar concentrations of the solutions in each of our two half cells. We use the naught symbol here to indicate that it is under standard conditions. This represents the energy difference per unit charge between the cathode and the anode. All reduction potentials are measured with reference to a standard hydrogen electrode, which we're going to look at more in class. And this is referenced with an E naught value of 0 volts. So in your data table on page 12 of your data booklet, you will find reduction potentials for all sorts of different compounds in reference to this standard hydrogen electrode. To determine the E naught value for a cell, we have a very simple calculation we need to do. We take the E naught value at the cathode, and we subtract the E naught value at the anode. So remember, E naught represents standard electrode potential. It is the ability of the half cell to attract electrons under standard conditions, thus undergoing a reduction. If it's a positive value, that means it's more likely to undergo reduction as compared to a negative value. Here's an example then. Calculate the standard cell potential of the following reaction, where we've got copper 2 plus zinc solid reacts to give copper solid plus zinc 2 plus. First thing we want to do is locate these within our data table, figure out which one is our oxidizing agent, which one's our reducing agent. Remember, our oxidizing agents undergo reduction, and they're found at the cathode. Reducing agents undergo oxidation. They are found at the anode. So our copper is at the cathode, our zinc is at the anode. To determine E naught, we're going to take E naught at the cathode, which is plus 0.34 volts, minus our E naught at the anode, which is negative 0.76 volts. When we add these together, we get plus 1.10 volts. So this would be the standard electrode potential, standard cell potential with copper and zinc as our two electrodes. One more note here, a positive value, so a positive value when we calculate E naught of the cell, indicates that a reaction is going to be spontaneous. If it's negative, it means that it is not spontaneous.